Till now, we had learned about various physical and chemical properties in the periodic table. One thing you need to remember is the fact that all of the properties in the periodic table in the end are dependent on the electronic configuration. The, the electronic configuration determines the location of a particular element in the periodic table in the end, and that in turn affects the various properties. Like, I mean, that does not affect, but for our understanding, the atomic radius, the ionization enthalpy, electron gain affinity, all of these are in relation to the electronic configuration. So the elements on the left side of the periodic table tend to lose electrons, whereas the ones on the right side of the periodic table tend to gain electrons. And this leads to the introduction or the recap of a very important topic, oxidation and reduction. Oxidation basically is the addition of oxygen or removal of hydrogen, and reduction is the addition of hydrogen or removal of oxygen. So here in this reaction, aluminium oxide is undergoing a reaction with hydrogen to lead to the formation of aluminium and water. And here, aluminium oxide itself undergoes the process of reduction because it lost the oxygen. And hydrogen is undergoing the process of oxidation because it gained an oxygen. Now, there's another definition for oxidation reduction that's more important, or rather, for now, this is the one we are concerned about. Loss of electron and gain of electron. So, oxidation is Le. So, the reason that I say LeO is because loss of electron hyphen oxidation. So, LeO. That's how you can remember oxidation means the loss of electron, LeO. And this is honestly the only way I was able to not understand, but remember the fact that oxidation involves the loss of electron, whereas reduction involves the gain of electron. So here in this reaction, magnesium gets a +2 charge, which means it lost 2 electrons, whereas chlorine is getting a minus charge, which means it gained an electron. So magnesium is undergoing oxidation, whereas chlorine is undergoing reduction. An oxidizing agent and a reducing agent. So substances which help in the process of oxidation are called as oxidizing agents. Quite simple, right? And the ones which help in reduction are called reducing agents. So an oxidizing agent will undergo reduction while a reducing agent will itself undergo oxidation. So by undergoing reduction, it is helping the process of oxidation take place. That's why it's an oxidizing agent. Whereas when this substance undergoes oxidation, this helps the other substance to undergo reduction. And so it's a good reducing agent. And in this particular reaction, aluminium oxide is acting as an oxidizing agent because it itself underwent the process of reduction, whereas hydrogen undergoes the process of oxidation. And so it's a good reducing agent. So our elements of group 1 and 2 are good reducing agents because they themselves get oxidized, whereas our elements of groups 16, 17 and all, they're good reducing agents because they're good oxidizing agents because they themselves get reduced. So the element oxygen is quite unique. The reason I say this is because almost all the metals which are obtained in the Earth's crust is in the form of the oxide. And due to its unique electronegativity, oxygen can actually react with most of the elements in the periodic table. And so the acidity or rather, the nature of the oxides are important for us to understand. So oxides uh, are basically categorized into 4 types: acidic, basic, neutral, and amphoteric. First of all, neutral oxides. Neutral oxides examples are carbon monoxide and water. The reason these are neutral is because on dissolution in water, they do not lead to formation of an acid or a base. So by now you would have understood. When it's a basic oxide, it leads to the formation of a base in presence of water, whereas an acidic oxide leads to the formation of an acid. So let's start with sodium oxide. Sodium oxide undergoes reaction with water, or rather dissolves in water to lead to the formation of sodium hydroxide. And sodium hydroxide, as we know, is a base. So when sodium oxide is quite base, is a very good base, it reacts with hydrochloric acid. It leads to the formation of sodium chloride and water. This is one of the very familiar reactions you would have learned in one of your previous years. Basically, acid plus base gives rise to salt and water. So sodium oxide is acting as a base. HCl is an acid. It leads to the formation of a salt, NaCl, and water. Acidic oxides, on the other hand, on dissolution in water, leads to the formation of an acid. So chlorine exists in two states. It has a 7 oxidation state and a 1 oxidation state. I'm sorry. But when it's in its 7 oxidation state is when it's highly acidic in nature, but not as much. I mean, it's the one oxide is not that acidic. So we're considering it 7. So Cl2O7 reacts with water to give us it gives us perchloric acid. So perchloric acid is actually a very strong acid. And when this particular oxide, which is quite acidic, reacts with the base, it leads to the formation of salt and water. And this salt is called as sodium chlorate. So basic oxide will get dissolved water to form a base. Acidic oxide will get dissolved water to form an acid. Amphoteric oxide act as both acids as well as bases. This means that in presence of an acid, this particular oxide will act as a base, and in presence of a base, this particular oxide will act as an acid. So HCl is an acid. Aluminium oxide will act as a base to lead to the formation of aluminium chloride. So aluminium reacts with hot dilute HCl to lead to the formation of aluminium chloride. Whereas aluminium oxide, on reaction with hot concentrated sodium hydroxide, here it's acting as an acid to lead to the formation of sodium tetrahydroxoaluminate. So basically, acidic, basic, and amphoteric and neutral. So acidic will act as an acid in the presence of a base. Basic will act as a base in the presence of acid. Amphoteric can act as both acid as well as a base, depending upon the environment it is present in. So here, across the period, here we're taking third periodic table: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. As we notice, the acidity of the oxide is increasing from left to right. And here you have aluminum oxide, which is amphoteric in nature. Whereas down the group, the basic nature of the oxide is increasing. Across the period, acidic nature is increasing. Down the group, the basic nature is increasing. That's why you have acidic, amphoteric, and you have basic. Here you have amphoteric, basic, and basic. Here, group 1, all of them are basic oxides. So with this, we complete the chemical reactivity as well as nature of oxides. Chemical reactivity, basically the elements of group 1 and 2 undergo the process of oxidation, loss of electrons, whereas elements of group, that is the right side of the periodic table, excluding the noble gases, undergo the process of reduction, that is the gain of electrons. And we had also learned about the acidic, neutral, basic, and amphoteric nature of various oxides. With this, we complete the chapter. We started with the genesis of the of the long form of the periodic table, and then we moved on to learning about the modern periodic law, that is a more long form of the periodic table. We've also seen various types of periodic table, which are used, but the long form is the one which is used by almost by everybody. We learned about nomenclature of elements greater than atomic number greater than 100, why it's the case. We learned about the various types of elements in the S, P, D, and F blocks, along with the metals, non-metals, and metalloids, how they're different from each other. And we learned about the periodic trends and properties of elements which basically all boils down to the atomic radius and the electronic configuration. Understand that, and then you'll find it very easy to understand all the other properties. So in the next video, we'd be discussing the index questions. So do check it out.